We're going to be taking a look at our rules of exponents. These rules tell us how to deal with terms when they have exponents on them. Now remember, let's sketch out here real quick. Remember all an exponent is technically it's a shorthand notation for repetitive multiplication. Now all that means is you take the base. Now the base is what is being raised to the exponent. So the 2 is the base, and of course the 3 is the exponent. Well, this tells you to take the base and multiply it by itself that many times. So 2 to the third, if we expand that out, would be 2 times 2 times 2, of course, which would be 8. Now we could do it the other way around. If I had a bunch of, say, like 4s multiplied together, I could condense this together using my exponent notation. So this is 4 times itself 5 times. So that would be 4 to the 5th. All right, I think we all knew that in the past, but let's take a look at what happens when we have variables involved and how the rules really apply. So let's start out here with our first rules of exponents. What happens if we're multiplying two things together? They have the same base but a different exponent. So here we have x to the n times x to the m. All right, so kind of the idea here, and let's just take a look at an example. Kind of like if I had x squared times x to the third. Is there any way we could put that together into one piece instead of two different ones? Well, since the bases are the same, and think about it like this. If we were to expand these out, x squared would be x times x cubed would be x times x times x, right? That's x squared, that's x cubed. Well, if we squeeze this back together, that's really x times itself 5 times. So what did we end up doing with these exponents? Well, all we ended up doing is really just adding them, right? Because here we're multiplying x by itself twice, there 3 times, which means we're multiplying x by itself a total of 5 times. So the way we write this out with our rules here, this is x to the n plus m. Now, the way we remember the rule, if we're multiplying and we have like bases, we add the exponents. All right, what about if we're dividing? What if I have x to the n over x to the m? Well, let's see here. Oop, dropping stuff. All right, let's see. What if I have like x to the 5th over x to the 3rd? What are we going to do with this? Well, let's expand these out again. So that's going to be 1, 2, 3, 4, 5 of them on the top, and 1, 2, 3 of them on the bottom. All right, now since we're dividing and everything here's joined by multiplication, we can just reduce, right? X divided by x would just be a 1. So that x can cancel with that x and gives me just a 1. That x can cancel with that x, that gives me a 1. That x cancels with that x is a 1. Of course, these are 1s on the bottom as well. So what do we end up with on the top? Well, we have 1 times 1 times 1 times x, which is just x squared. And on the bottom, I have 1 times 1 times 1, which is just 1. So we ended up with just x squared. So what actually happened here as we reduced? Well, kind of thing like this. We canceled the ones out, so when we cancel, we're reducing this number. So what we really did is we took away 3 x's from the top when we did that. So when we do this, when we're dividing and we have like bases, it's going to be the top exponent minus the bottom exponent. All right, but it's got to have like bases. All right, let's try another one. What happens if I take an exponent and raise it to an exponent? Kind of like this. What if I had x to the n raised to the m power? So something like this. What if I have x squared cubed? All right, well, let's expand out all this mess and see what this is actually telling me to do. Well, the cube on the x outside tells me to take x squared and multiply it by itself 3 times. Now, I'm going to go ahead and use another rule that we've established so far. We could expand all that out. But if we know for multiplying we have like bases, according to our first rule, we're just going to add those exponents. This is all multiplication, they all have like bases, so we're going to add those exponents. 2 plus 2 is 4, plus 2 is 6. So what does it look like we did with these exponents? Well, it looks like we multiplied it. That's exactly what's happening here. So if you have a power raised to a power, you multiply. All right, let's take a look at a couple more. What if we have more than one thing inside the parentheses raised to a power? Something like, well, what if we have a times b to the third? Well, again, expanding this out, let's see what we got. That'd be a times b, a times b, a times b. Well, remember, multiplication is a commutative, which means you can multiply in any order you want, right? 2 times 3 is the same thing as 3 times 2, which means I can multiply these in any order that I want. So I can multiply all the a's together and all the b's together, and then if I squeeze this together, that would be a to the third, b to the third. So if we have things joined by multiplication inside of parentheses raised to a power, what did we end up doing? We just raised everything on the inside to that power. So the way that a rule like this would be written, if we have something like ab to the n, that would be a to the n, b to the n. Or if everything's joined by multiplication, then everything on the inside gets raised to that power. Now the same basic idea is going to work with division. I'm just going to squeeze it over here. What if we have a over b to the third? Well, that'd be a over b, and a over b. Well, we know when we have fractions, we're going to multiply fractions straight across. So if we multiply straight across top, a times a would be a to the third, b times b would be b to the third. So the same basic idea. In fact, we're going to condense this into one rule when we say it. The way that you want to memorize this rule, and this is really one rule, we kind of split apart into two small ones. Inside parentheses, if things are joined by multiplication or division, all you do is raise everything inside the parentheses to that power. All right, the next two are a little bit more challenging, at least to understand. The next one is anything to the 0 power is 1. Now this on its own doesn't even quite make sense with the question. Like if I said, what is 2 to the 0 power? Well, remember what an exponent tells you to do. Take the base and multiply it by itself that many times. How do you take a 2 and multiply it by itself no times? You see what I mean? All right. Now to show you why the answer is actually 1, like this does, we're going to start out, let's just do some numbers. What if I said 2 to the third is equal to 8, right? 2 times 2 times 2 is 8. Now, all I'm going to do is I'm going to start dividing both sides by 2, just to kind of see what happens. On the left-hand side, I'm going to use my rules of exponents. On the right-hand side, they're just going to stay numbers. So what would 2 to the third divided by 2 be? Now remember, it's just 2 is 2 to the first. So according to our rule here, if we have like bases and we're dividing, it's the top exponent minus the bottom exponent. So that's 2 to the third minus 1, which is 2 squared. So if I divide the left-hand side by 2, I get 2 squared. You divide 8 by 2, you get 4. Now notice it's still a true statement, right? 2 squared is 4. Now we're going to do the same thing again. I'm going to divide both sides by 2. So 2 squared divided by 2 would be 2 to the 2 minus 1, which is 2 to the first. So 2 to the first. If I divide the right-hand side by 2, 4 divided by 2 is 2. And again, notice we get a true statement, right? 2 to the first is 2. So if we do this one more time, 2 to the first divided by 2, which would be 2 to the first, that's 2 to the 1 minus 1, which would be 2 to the 0. So on this side, we get 2 to the 0. On that side, 2 divided by 2 is 1. Okay, so notice that as we went down here, we see that 2 to the 0 power is 1. So you can kind of deductive reasoning that through and say, yeah, that kind of makes sense why that might be true. Now notice this would have worked, I used 2 just because it's a small number. This would have worked for any number. Now there's no reason, and I'm going to go ahead and get some of my scratch work here out of the way. There's no reason that we can't keep going, right? Why don't I just keep going and see what happens? What if I take 2 to the 0 and divide it by 2 to the first? Well, that'd be 2 to the 0 minus 1, or 2 to the negative 1 power on this side. And what do I get if I divide 1 by 2? Well, 1/2, right? 1 divided by 2. If I keep going, let's see, it's going to be a little bit messier. 2 to the negative 1 divided by 2 is going to be 2 to the negative 1 minus 1. Here we're subtracting or adding. They're both negative, so we add them together and keep the sign. So the next one would be 2 to the negative 2. And what is half of a half, right? I'm just dividing that by 2. So half of a half is a fourth. Now, I'm going to just go, you can kind of see the relationship there. Remember, 4 is really 2 squared. All right, if we were to do this again, I'm not going to scribble it out over here. You can kind of see what happens. When we divide by a power of 2, the exponent goes down by 1. So on this side would be 2 to the negative 3. And half of a quarter would be an eighth, which, of course, 8 is 2 to the third. So you can kind of see what that negative does. If you have a negative exponent and it's on the top, like this on the top of the fraction, it actually moves it to the bottom of the fraction, then the exponent becomes positive. And it works the other way too. If you had a negative on the bottom, it'd actually move it to the top. So we have 2 more rules that I'm going to put as one rule down here, and it's kind of coming from this right here. If you have x to a negative power, we can rewrite that as 1 over x to the positive power, or if you have 1 over x to a negative power, we can write that as positive. So this last rule, the idea is if you have a negative exponent, it either moves it from the top to the bottom or the bottom to the top. It moves it to the other side of the division bar, and then the exponent becomes positive. Now, these are our basic rules of exponents. Some textbooks might throw in some more that may be combinations of these, but these are the fundamental ones that we need to know. Your book may also name these. They go by a lot of different names. This is generally called the product rule, because product for multiplication. Quotient rule, well, quotient for division. This is called the power rule, because we have a power. These two are kind of put together. A lot of times they're called like the extended or the expanded power rules. This is a zero power rule, because we have a zero power. And these are generally called the negative exponent rules. You don't necessarily need to know the names of them specifically, but you absolutely need to know how to use these. Now, in our next video, we are going to take a look at how we use these rules to help simplify expressions.